Hi there, Abdullah here from Team Nautical. We are developing an advanced ship routing solution that optimizes cargo shipping by dynamically generating routes to avoid hazardous weather, manage speed and fuel, reduce CO2 emissions, and boost efficiency. The platform offers an intuitive interface with real-time data visualization and interactive maps. Moving on to our prototype, here we have the ship's parameters. The first parameter which we have here is the fuel efficiency. It is measured in terms of liters per nautical mile, and this means that the lower the number, the higher is the efficiency, and vice versa. Second parameter which we have here is the ship's speed, which is measured in terms of nautical miles per hour. The lower the number here has a negative impact on the efficiency. And a point to note is that the real-time weather data for the default date set in our code is directly being accessed from the netcdf file provided by the Indian National Center for Ocean Information Services, and that's done for the route for Rajula to Kochi. Running upon the simulation for fuel efficiency set to 5 and ship speed set to 20, we get an interactive map showcasing the route in green color and also the coordinates also associated with it in terms of longitude and latitude in terms of degrees, and we also get a best cost of around 13,894. Reducing the fuel cost or the fuel consumption, to be more precise, should have a better impact or a positive impact on the efficiency of this route. Running the simulation, this yields a best cost of around 13,599. This means that the lower cost of 13,599 indicates that this is a more efficient route. Thus, lowering the ship speed has a negative impact on the route, and here we have the efficiency of the route increase in negative way, wherein the cost has been increased to 13,604 from 13,599. A point to note is that the artificial neural network which we are using to fine tune the optimal route generated by the ant colony algorithm is done via the data provided by the previous routes and their various parameters included, like the weather data, the fuel efficiency of the ship, and the ship speed. Here we have an Excel sheet representing the data for the summer climate. Now let me change that to the monsoon climate. This should have a negative impact on the efficiency of the route. So let me save the data here and run the simulation. Here we see that the route has increased its best cost, indicating that the route's efficiency has taken a toll on the negative side. In this part of the prototype, we'll be discussing on how the user can visualize the meteorological data like sea surface temperature, wind speed, wind direction, etc. In this case, we'll be talking about wind speed in terms of meters per second. The default date is selected 25th of August 2024, and the default ocean selected is Indian Ocean, the northern part. So now the user will be provided by the data being plotted onto a map which has coastal boundaries and the country boundaries, and the data will be highlighted by a color range of blue indicating on the lower end and red indicating on the higher end. Let's say if the user wants to see the animation of the real-time data, so the user hits the start animation button wherein the user can see the real-time data in intervals of 3 hours. But this is with respect to the data set which will be provided, and the user has the freedom to stop the animation. And let's say if the user wants to access the data for 26th of August 9 p.m. so this will be a particular time frame, so the user can directly select that and get the data for 26th of August 9 p.m. and visualize it. Thank you.